Here's a question that 90% of people cannot solve without a calculator. How many digits does 2 to the power of 1000 have? Take a moment. Think about it. Pause the video if you want to try. Ready? Let me show you the clever trick. To solve this, we first need to understand a simple pattern. Let's think about how many digits a number has. 10 to the power of 0 equals 1, and 1 is a one-digit number. 10 to the power of 1 equals 10, and 10 is a two-digit number. 10 squared equals 100, a three-digit number. 10 cubed equals 1000, a four-digit number. 10 to the power of 4 equals 10,000, a five-digit number. Do you see the pattern forming? Let's put it all together. The number of digits is always one more than the exponent of 10. 10 to the power of 0, one digit. 10 to the power of 1, two digits. 10 to the power of 2, three digits. 10 to the power of 3, four digits. 10 to the power of 4, five digits. The exponent tells you the number of digits minus 1. Now let's think about this more carefully, using a table. If a number n lies between 10 to the power of d minus 1 and 10 to the power of d, then n has exactly d digits. This is the key insight we'll use. Let's test this with a simple example first. Take the number 324. We know that 100 is less than 324, which is less than 1000. In other words, 10 squared is less than 324, which is less than 10 cubed. So 324 fits between 10 to the power of 2 and 10 to the power of 3. That means d equals 3. And yes, 324 is a three-digit number. The rule works perfectly. Now let's write this as a general argument. If a number n satisfies 10 to the power of d minus 1 is less than n, which is less than 10 to the power of d, then taking log on both sides gives us d minus 1 is less than log n, which is less than d. This means log n lies strictly between d minus 1 and d. Before we go further, we need a quick concept. The floor function. The floor of a number just means round it down to the nearest integer, no matter what. So the floor of 3.14 equals 3. The floor of 2.73 equals 2. And interestingly, the floor of negative 1.53 equals negative 2, because we always round down. Now here's where it connects back. We said d minus 1 is less than log n, which is less than d. Take, for example, 3 is less than 3.14, which is less than 4. The floor of 3.14 equals 3. But there is a special case to watch. If log n is exactly an integer, we need to include the equals sign. So more precisely, d minus 1 is less than or equal to the floor of log n, which is less than d. From this, we can now derive the formula for the number of digits. Since the floor of log n is less than d, and also at least d minus 1, the value of d equals 1 plus the floor of log n. That's our formula. The number of digits of any number n is 1 plus the floor of log n. Now let's use this formula on our original question. 2 to the power of 1000. Plug it in. d equals 1 plus the floor of log of 2 to the power 1000. Using the log rule, log of a to the power b equals b times log a, we get log of 2 to the power 1000 equals 1000 times log 2. And the value of log base 10 of 2 is approximately 0.300102999566. So 1000 times log 2 equals 1000 multiplied by 0.300102999566, which gives us 301.02999566. Now we apply the floor function. The floor of 301.029999566 equals 301. We just round it down to the nearest whole number. So D equals 301 plus 1. D equals 302. 2 to the power of 1000 has exactly 302 digits. That's the clever trick. You don't need to calculate the actual number. You just need logarithms and the floor function. 2 simple tools, and you get the exact answer in seconds. 90% of people reach for a calculator. Now you know why you don't need one. If you found this useful, like and subscribe for more math tricks like this. See you in the next one.